Welcome to the next session, my dear friends. In the previous session we have discussed about the particle removal efficiency of the filter and the velocity of backwash and all those things. And now in this session we are going to discuss what is meant by particle breakthrough and what is meant by time for reaching terminal velocity of a filter, and we are going to discuss the design of filter, comparisons of rapid sand filter, slow sand filter, and what is meant by pressure filter, and what are the problems, operation troubles of a filter. So we have to learn all these things. I think in 1 or 2 sessions we will learn all these things. Now, so first of all, here, when to clean the filter, when we need to clean the filter, how we will know? We will know from 2 factors. One is time of particle breakthrough. Okay, so TB is time for particle breakthrough. So what is meant by time for particle breakthrough? So the term, the name itself is saying time for particle breakthrough. So that means the filter media, when the filter media is filtering the water, then the particle cannot break through the filter media. When the filter media is filtering the water, then the impurity particles cannot break through the filter media. If the particles are breaking through the filter media and reaching the effluent outflow, then the particle no more removed in the filter media. The particle is breaking through the filter media and again entering into the effluent. That means the filter media is no more filtering the water. So what is meant by time of breakthrough then? What is meant by time of breakthrough? The time required for reaching particle breakthrough, the time required to reach particle breakthrough, that is turbidity in the effluent, is more than 2.5 NTU. So when the turbidity in the effluent is more than 2.5 NTU, then that time is called time for particle breakthrough. So how much time after the filter commissioning, after the filter commissioning this thing is happening. So that is the time of particle breakthrough for that filter. Time of particle breakthrough for that filter. And next one is time of terminal head loss. Time for reaching terminal head loss. Time for reaching terminal head loss. So that means generally when we are using the filter, so the filter pores will get clogged, and at some point of time or other the head loss will be increasing. So if the head loss is more than 3 meter, okay, so when the head loss is more than 3 meter, then it is called time for reaching terminal head loss. For a particular filter, how much time it is taking to have a head loss, how much time it is taking to have a head loss more than 3 meter. That is nothing but time for reaching terminal head loss. Time for reaching terminal head loss. These two are the times which is a reference times for cleaning any filter. Now, so these times will be changed by the specifications of the filter. So effect of filter specifications. So effect of filter specifications on TB and TH. So the first specification of filter, that is filter depth. So if we increase the filter depth, so if the filter depth is increased, then what happens to TB and what happens to TH? See, when the filter depth is increased, TB will increases. Because since the particle in the water will have the opportunity to interact with more collectors. That means when the depth is increased, so the filter particles are increasing. The filter media particles are increasing. That means when the impurity is missed at one particle, it can be catched by the other particle. When the number of particles are increasing, because when your depth is increasing, number of filter media particles are increasing. When the number of filter media particles are increasing, the impurity will have more number of interactions. It has to interact with more number of filter media grains. So if one grain is not capable of catching that impurity, other grain may have an opportunity to catch it. So when the depth is more, then the opportunity of catching that impurity is more. When the opportunity of catching is more, then the effluent, getting the effluent turbidity more than 2.5 NTU takes little more time. It takes little more time because the depth of the filter media is more. And what happens to the terminal head loss? It decreases. Terminal head loss time will decreases as the depth of the filter media is increasing. As the depth of the filter media is increasing, water is encountering more resistance. Water has to pass this greater depth, because of which more head loss will occur. So this head loss, so 3 meter head loss will build up very fast as the filter media depth is more. So the resistance of the filter media is more. So that is why the time required for reaching the terminal head loss will decreases when you increase the filter depth. This is one specification. Another specification. Next specification is superficial velocity. That is rate of filtration, ROF. Superficial velocity or ROF. So both TB decreases and TH also decreases when you increase the superficial velocity. A simple example is slow sand filter and rapid sand filter. Slow sand filter cleaning time, that means cleaning time is what? Time of particle breakthrough, time of terminal head loss. The cleaning time. So cleaning time is 1 to 3 months. Once in 1 to 3 months. Whereas if you go for the rapid sand filter where the superficial velocity or the rate of filtration is 30 times of slow sand filter, then what is the time of breakthrough now? It is 1 day to 3 days or 24 hours to 48 hours. That means when you increase the rate of filtration, time of particle breakthrough, because more water is coming, so the impurities, so if more is the water coming, more is the impurity concentration is coming. So if more is the impurity concentration is coming, very fast the filter will get exhausted, and it cannot it no more it can stop the effluents. Easily particle breakthrough will come very faster as the number of particles are coming onto the filter. So easily, very fastly, the filter will lose the capability of the particle breakthrough. Okay, so that is why generally both will be decreasing when the superficial velocity is increased. And third one is the concentration, initial concentration of the impurities. So here in this case also both will decreases. TB is decreases and TH also decreases. So if you look at the previous concept which I have told, rate of filtration, if we increase, not only water increase, impurities concentration also increases, isn't it? So during the rate of filtration increasing, more water is coming as well as more impurity is also coming. So if more impurity is also coming, that is why these two are decreasing. If water is less but impurity concentration is more, then in that case also both will decrease, because if the impurity concentration is more, then very fastly the filter will get exhausted because of the more concentration of impurity. So both are actually, the effect of both are same but in a different way. But they are in different way. It is happening because of increase of rate of filtration. It is not because of rate of filtration. It is simply the pollution of the water. The pollution in the water is more. That is why the concentration of impurities is more. Okay. Now next one is flock strength. Flock. So generally, if we bring the water from secondary sedimentation tank, if you are bringing water into the filter from the secondary sedimentation tank, then you will bring it from, then the water which is coming will have unsettled flock in it. Unsettled flock will present. That unsettled flock now will enter into the filter. Now it will enter the filter. So because of which, what happens to TB and what happens to TH? So obviously TB will increases. TB will increases because of the flock, and TH decreases. So because of the flock will take the pores. The flock will take the porous spaces of the what is they say that of the filter media, because of which what happens, so it won't allow any kind of turbidity to pass through the filter media. So at some time or other, completely the flock strength is utilized. Okay, so the particle detachment, so due to the flock present inside the water which is trapped in the filter media, so this flock will not easily leave the particles into the effluent, because this flock is having a gelatinous nature. It will, the particles which are escaping from the filter media can be holded by the flock. That is why the TB will increases when the flock strength is present. And TH decreases because the flock is obstructing the path of the water. That is why easily very fastly the head loss will appear in the water, because of as the flock is occupying the porous spaces, which increases the resistance of the filter media, because of which time for reaching the terminal head loss will decreases. Okay, that is the effect of flock strength on TB and TH. And next is collector diameter, effect of collector diameter. So collector dia. So here what is meant by the collector? So here presence of lesser number of collectors in the filter media. So collector diameter means what? The filter media grains. Collector means here who? The filter media grains. So diameter of the filter media, we can also say diameter of the grains of filter media, or we can say it as collector diameter. Okay, collector who collects the impurity, collector diameter. So flock strength increases, everything here increases. Okay, collector diameter increases, then TB, collector diameter increases, TB decreases, TH increases. So when the collector diameter is larger, then the porosity is more. When the size of the grain is more, then the porosity is more. So when the porosity is more, easily the effluent can get the turbidity outside very easily. Very easily the effluent can get this amount of turbidity. Okay, so that is why when the collector diameter is larger, then what happens? Easily the particles will remove. So this will be result in lesser number of potential interactions. So when the size of the collector dia is lesser, so then the surface area will be more. Because of more surface area, more interaction is possible. But whereas if the collector diameter is larger, which will cause lesser surface area, which causes less amount of interaction, because of which the particles can easily escape through the filter media. Whereas TH, because the porous spaces is larger, so increases collector diameter, so number of particle will be collected here. Because of the more collector diameter, the porous spaces is larger, so because of which the head loss occurs little late, because here collector diameter is larger, means it collects less number of particles, because of which the spaces present inside the collector, between the collector particles, will not get clogged easily. So it takes some more time. So that is why time for reaching terminal head loss will be more here. And the last one is the porosity. Porosity increases, then the same effect here also. Both effects are same, but in a different way. Here when the collector diameter is more, then the obviously porous spaces will be more. When the size increases, then porous spaces increases. Similarly, directly given that porosity is increased, when you increase the collector diameter, that is the indirect effect by which the porosity is increasing. So if you directly increase the porosity, that means the same effect which you have seen earlier, that will happen now also. Are you getting my point? Collector diameter if you increase, then porosity will increase. So that is why TB is decreasing, TH is increasing. When you increase directly porosity, then the same effect will prevail. Okay. So this is the time for particle breakthrough and time for reaching terminal head loss. These two times will indicate the filter cleaning period. These two indicates the filter cleaning period. It depends upon the specifications of the filter. We can alter it by changing the specifications of the filter. Okay, by changing the specifications of the filter. So from this also previous gate question came, that is why I have explained this concept. Next is operation troubles of filter. So when we are using filter, so what kind of troubles we will face, and what are the remedies of that troubles? Generally 99% all the troubles are arising due to improper maintenance of the filter. If we properly maintain the filter, that means if you properly clean the filter within the stipulated time, that means whenever it is raising the alarm, that means when the head loss is reaching 90% of the total head of the water, or when the filtered water turbidity is more than 2.5 NTU. So all these things are indications that the filter needs to be cleaned. So at that time, if you react and you clean the filter, then many of the problems can be avoided. Okay, the major remedy for operation problems in the filter is proper cleaning of filter. So let us see what are the operation troubles. Operation troubles of filter. The operation troubles of filter. So first one is air binding. See here, air binding means when the filter is when the filter is having operated by industrial waters, generally industrial water or any kind of water. So there will be some entrapped impurities present in the water. So whatever the entrapped impurities generally exceeds the static head of the water, exceeds the static head of the water. See, when you are sending water into the, when you are sending water into the filter, okay, so this is a filter. So there will be head, for example this is a sand bed. So here if you insert a piezometer, here if you insert a piezometer, there will be difference of head. So there will be difference of head. So this is head loss which is causing the flow, right? This is head loss which is causing the flow. When completely the water coming out of the filter is completely stopped, so no water is coming out of the filter now, because completely the filter is clogged, no water is coming, though you are sending water from the top. Then what happens in this bottom layers, in this bottom layers a negative pressure will develop. Yes, there is no water on one side, on the other side you are loading it with fresh water, so high pressure on one zone, low pressure on another zone, so causes negative pressure to develop. So this negative, during this negative pressure, what happens when the negative pressure develops, then whatever be the dissolved gases present inside the water at the bottom layer, though that will get evolved, because they will be having less vapor pressure than the pressure existing outside. Then what happens, so all these dissolved gases will come out of the water, will come out of the water and occupy this air will occupy the void spaces inside the porous media, the filter media. Okay, so this air particles obstructs the flow of water through filter. So now whenever the air comes, water cannot flow, water cannot flow. So this kind of air which is avoiding the flow of water, the flow of water is nothing but air binding, it is nothing but air binding. This can be avoided by cleaning of filter. Proper cleaning, I have already told you, proper cleaning should be done. And when negative head is coming, reaching 1.2 meter, so generally here we use manometer, I have told you already, to measure the heads. So when the negative head it is reaching 1.2 meter, immediately you need to stop the filter and you need to keep it for maintenance. So this is how we can avoid air binding. So air binding means when so negative pressure develops inside the filter, then the entrapped gases in water comes out and occupy the porous spaces, and occupy the porous space in filter media, which obstructs the flow of water. So it can be avoided by proper cleaning of water, cleaning of filter periodically, and cleaning of filter should be done when negative head is about 1.2 meter. So when the negative head is about 1.2 meter, then we must keep that filter at maintenance. Okay, so or else when normal head is reaching 2.5 to 3.5 meter and the negative head is reaching 1.2 meter, we need to immediately stop the filter and we need to keep it for maintenance. And next is mud ball formation. Next is mud ball formation. See here, mud ball formation. Mud from atmosphere enters into the main filter and gets deposited on the surface of filter media. Due to inadequate washing, these mud particles enters into the bottom layers and combine with entrapped impurities and grow in size, resulting in the formation of mud balls. Okay, so here, mud ball formation is very simple. That means whatever the impurities present in the atmosphere will come onto the surface of the filter, and then they will travel along with the water into the filter media. And if there are any kind of conglomerating materials like such as lime impurity, one kind of impurity which can attract other particles, which can bind other particles, those kind of entrapped impurities which are capable of cementing in nature. So now these particles will come together, and if you don't identify them when they are smaller, and if you don't remove them, then their size will grow bigger, and even sometimes they will interfere the backwashing also. They will sometimes, so this mud ball may even reach to the gravel also. So first in the beginning it will be confine itself to the filter media, and then it may also reach up to the base material like gravel, and then after once it reaches the gravel media, then it also obstructs the backwashing too. That means you cannot even remove it. If it is present in the sand media, then we can remove it by the possibility is there, we can remove it by backwashing. Once it enters the gravel also, then it is very tough to us to remove that mud balls. So that is why, so this also remedy is simply remove it by proper maintenance of the filter. Whenever it is head loss is more, then we need to maintain it. So to avoid this, adequate backwashing is necessary. Okay, and if still the problem is sustaining, then we need to submerge this filter media in caustic soda. So we have to apply caustic soda, and we need to soak the filter material in caustic soda for cleaning with OH minus ion. Okay, so that is the remedy of mud ball formation. So mud ball formation is the dust which comes from environment enters into filter media and travels along with water it binds with the existing impurities, present in the filter media and forms mud balls. mud balls. If not noticed in advance, it will extend to base material gravel also, and creates problem for backwashing and creates problem for backwashing also. To remove this, to avoid this, cleaning of filter periodically is necessary, and still the problem persists. Soak the filter media in caustic soda. So OH minus ion will remove the mud balls. OH minus ion will eat away the mud balls. That is another operation trouble. So next operation trouble, cracking of filter. So cracking of filter means, see, whenever we keep the filter in breakdown, okay, so for longer durations, so filter has got repaired and you are not at all taking care of that filter. After some time, what happens? So filter is always contains water when it is in operation. Filter always contains water when it is operation. So it is completely under supersaturated state or saturated state. When you suddenly keep the filter aside, okay, so and you are not at all tackling about, you are not at all repairing it, then what happens? So whatever the moisture present inside the filter medium will now get evaporated. So drying is taking place. So complete drying, so alternative wetting and drying of the filter media, what happens? Causes shrinkage inside the filter bed. If there is any kind of material which is present, which is having more shrinkage, then further it causes more shrinkage in the filter media, causes separation of filter bed. And if you don't notice this happening and you are still using the filter media, then once the filter media bed is separated, then it is no more filter. Once the porous, anywhere at any location, if the filter is opened, simple, if you take a small mesh, a small sieve, if somewhere I cut the sieve and rest of the sieve is good, does you say that it is a sieve? So the big hole will allow all the impurity out. So that is why here, once the sand is filter media is cracked, means we cannot use the filter media. So we need to completely remove the sand and we need to relay the sand and everything. It is like a new commissioning of filter media. Okay. So what is cracking of filter? Cracking of filter means, so alternative wetting and drying of filter media, alternative wetting and drying of filter media causes shrinkage, cracks in filter media. Further loading the filter media induces pressure. Further, if you don't notice it, further loading on filter media widens the crack and makes the filter unfit for filtering, So the remedy to avoid this, the filter media always kept in moist condition. So always we need to keep the filter media in moist condition. Otherwise what happens? This problem will arise. So these are the air binding, formation of mud ball and cracking of filter. These are the important operation troubles of rapid sand filter. All the operation troubles are of rapid sand filter. So in case of a slow sand filter, so this mud ball formation, whatever the mud ball formation, that will be a problem in the slow sand filter also. We remove in slow sand filter using cracking it, racking it. So by different ways we remove these mud balls in case of slow sand filter. So these are the operation troubles of the filter. In the next session we are going to establish the comparison between the slow sand filter and rapid sand filter, and we will discuss some topic about pressure filter, and also main part, that is design of filter, is yet to be covered. These things we will cover in the next session. Thank you so much.